Hi, in this video we're going to talk about the rules of exponents. So be sure to hit that subscribe button and stay tuned. Hi, let's talk about exponents. So there are only a few exponent rules that you'll need to know in your college algebra class. So I'll go through them all and show you simple examples for each one. So the product rule. This rule comes into play when you have the same number being raised to two different powers and being multiplied together. So if I have some number a raised to the power n times that exact same number a, but it's raised to a different exponent m, in this case I can just add the exponents together. So for example, let's say I have the number 2 and it's raised to the power 3, and I'm multiplying it by the number 2 raised to the power 4. So without knowing the rule, I can figure out what this is by, so I know what 2 cubed is, that's 2 times 2 times 2, so I'll just write that down. And then I know, so this is the dot from here. I know what 2 to the power 4 is, that's just 2 times 2 times 2 times 2. And then if I count all my 2's, I've got 7 of them. And so I can write this as 2 to the power 7. So for example, if I have the number 3 raised to the power 5 times the number 3 raised to the power 8, I just add them together. This is 5 plus 8 as an exponent, which is 13. So that's 3 to the power 13. As a math teacher, I would want to see your answer 3 to the power 13 and not whatever number that is if you use a calculator. So that's the product rule. The quotient rule is similar, except it replaces multiplication with division and addition with subtraction. So in this case I have a number a raised to some power n, and it's divided by that same number a raised to some different power m. And in this case you subtract the top minus the bottom. And we can see that by working out a simple example. And by the way, if you have to take a test and you forget one of these rules, I would just make up a simple example. I'm making up this example with small numbers, keep them all different, and then just work it out by hand, and you can it'll help you remember the rule. So let's say I have 3 to the power 5 divided by 3 to the power 3. So I just said let's keep all the numbers different. Let's make that a 4. So on the top I have 4 to the power 5, which means 4 is multiplied by itself 5 times. So I'm just going to write that out. And on the bottom I have 4 is raised to the power 3, so 4 times 4 times 4. Now, I know how to cancel things on the tops and bottoms of fractions, so I'll cancel this 4 with that 4, and I'll cancel this 4 with that 4, and I'll cancel this 4 with that 4. And that leaves me with a 1 on the bottom, and on the top 4 times 4. So that's 4 squared. So if you notice the exponent 5 and 3, 5 minus 3 is 2. So for example, the number 6 raised to the power 17 divided by 6 raised to the power 5 is 6 raised to the power 17 minus 5, which is 12. So the next rule is called the power rule. And this is when an exponent is being raised to an exponent. So in this scenario, I have a number raised to some power n, and that quantity, that whole quantity, is being raised to a different power m. And in this scenario, you multiply those exponents. So I've got a to the n times m. So for example, and if you forgot this rule, this would be an example of the example that you come up with to help yourself remember the rule. Let's say I just have small numbers, 2, let's say 5 raised to the power 3, and all of that raised to the power 2. So without knowing the rules, I know what a square means, right? A square means I'm multiplying that quantity by itself. So this is 5 cubed times 5 cubed. That's nothing new, right? And I know what 5 cubed is. 5 times 5 times 5. And the same. And then if you look at how many 5s you got, you have 6 5s. And then light bulb goes on, oh yeah, 6 is 3 times 2. So I can just multiply. This is 5 to the power 6. So for example, 7 raised to the power 8, and all of that raised to the power 3. Well, that's 7 to the 8 times 3, which is 7 to the 24. So the next rule is negative exponents. So a negative exponent, I've always liked these because it's like we've come up with a useful way to use the notation that still makes sense. There's kind of a gap left. There's kind of a gap in the notation. If I write 5 to the negative 2, so usually the exponent tells you how many times you're going to multiply this number by itself. Well, I can't multiply 5 by itself negative 2 times. That doesn't make sense. So what this negative sign means is that I need to write this quantity in the denominator of a fraction with the same exponent as a positive number. So this is equal to 1 over 5 squared. So it means you want to take the reciprocal of 5 squared. That's what the negative sign means. And so that's 1 over 25. So in general, a to the power negative n is equal to 1 over a to the power n. So for example, if we look back at the quotient rule, when I made up this example, I was sure to make the number on top larger than the number on the bottom. I did 5 on the top and 3 on the bottom, and then I did 17 on top and 5 on the bottom, so that our answers would be positive. But you don't have to do that. Let's do an example where the exponent on the bottom is bigger. So maybe I'll just say simplify as the instructions. Simplify 5 squared divided by 5 to the power 6. Well, let's go through it once without using the rule. Maybe we'll just use the rule at the very end the first time. So I've got 5 times 5 on the top, and on the bottom I have 6 5s. 1, 2, 3, 4, 5, 6. Times. So I'm going to cancel things here in this fraction. 5 cancels 5, 5 cancels 5. So on the top I've got a 1. On the bottom I've got 5 times 5 times 5 times 5. So that is 1 over 5 to the power 4. But we know that if a quantity is in the denominator of a fraction and being raised to a power, then I can write that as the number in the numerator, but being raised to a negative fraction, exponent, negative exponent. So same example, but this time I'll just use the quotient rule. We already have the quotient rule. So I'll say with quotient rule. So this is equal to 5 to the power of the exponent on top minus the exponent on the bottom. So 2 minus 6. It's always top minus bottom. Don't try to memorize the rule based on the larger number or the smaller number. It's top minus bottom. So 2 minus 6 is negative 4. So that's nice. That's easy. So the quotient rule still works even though the answer is negative, which I really like about the negative exponent rule, personally. So another way to use the power rule is with a fractional exponent. Let's talk about those. So a fractional rule is more commonly seen as a radical. So if you just look at, if you just think about a square root, that's actually a 1/2 exponent, and that's a second root. But there's also a cube root, which is a 1/3, and a fourth root, which is a 1/4, and a fifth root, which is a 1/5. So a square root is a 1/2 exponent. So if I write the square root of 5, that is the same thing as 5 to the power 1/2. And I don't mean to just say they're equal. I mean it's a different way to write the same number. So I'm not trying to say this is an equation. I'm trying to say these two things are equal. They're just different ways. It's writing the same number with different symbols. So that's why I use the 3 lines on the equal sign. It's like saying it's a definition or it's congruent or something like that. And if you write a cube root, so if I write a cubed root, you'll see the little 3 up there. Well, that is 5 to the power 1/3. And so on. You can just keep going. You can have any root. The fourth root of 5 is 5 to the power 1/4. And so, by the way, so a square root is a number that you have to multiply by itself to get the original number, Well, a cube root is a number that you have to multiply by itself 3 times to get the original number, and so on. And you might, so when there's a square root, you can put the little 2 here, but you don't usually see it there. It's just kind of implied. If you don't see one, you know it's a square root and not some other root. So in general, I could say the nth root and put a little n in the radical. And so, for example, so this is really just notation, you know. This radical sign is the same as a fractional exponent. So if I ask you to simplify, and your teacher might have a different definition of the word simplify. In my book, it just means write it with the fewest symbols possible. That's how I think of it. So if I say simplify the 5th root of 3 to the power 7. Well, I know what a 5th root is. It's a 1/5 exponent. So I would write, you know, just one step at a time. So let's keep the 3/7. Since it's more than one number, it's a number and an exponent, I'm going to wrap it up in parentheses just to be safe. But the 5th root is the same as a 1/5 exponent, so I'm going to write 1/5 up here. And now I'm in the situation where I've got an exponent raised to an exponent, and that's a power rule. And in that scenario, you multiply these exponents. So this is 3 to the 7/5 power. So let's combine a couple of these together. What if I said the 3rd root of 2 to the power 5 divided by the 5th root of 2 to the power 3? So that looks that's a crazy looking number, but the base is 2 in the top and the bottom, and it's just a bunch of exponents and power rules and quotients and whatever. So let's just do one thing at a time. Let's see, the top is 2 to the 5th power, and that cubed root is a 1/3 exponent. And on the bottom I've got 2 to the 3rd power, and that radical is a 1/5 exponent. So now I can use the power rule. On the top, I get 2 to the 5/3, and on the bottom, you do the same thing, multiply the exponents, and you get 2 to the 3/5. And now I've got a quotient rule. So the quotient rule is always the number on the top minus the number on the bottom. So this is 2 to the power of 5/3 minus 3/5. Now I got to do a little algebra, a little arithmetic. Let's see. I need a common denominator, so let's go with 15. So that means, and this is 25 over 15 minus 9 over 15. And it just came to me. Notice how I'm working out these fractions, getting a common denominator and stuff. The 2 is not really involved right now, but I'm still writing it, and I'm just doing my math up here in the exponent. I've seen people, when I used to teach classes, I've seen the mistake where somebody their mind gets on a tangent where I'm going to simplify this exponent, and I do a lot of work with my fractions and I simplify it, and then that's the answer, and they forgot that it's actually an exponent and there's a larger component to the answer. This is just one piece of it. So I always make the practice of writing out the entire line, because another thing, I'm writing an equal sign here, and in my mind that means that whatever I'm writing here is equal to the previous thing that I wrote down. And if I don't write that 2, then that equal sign is not true. And I just try to, make it simple by, even if it takes me some more time, I always write out everything. Even if I'm only working on part of it, I always write out everything. So 25 minus 9 is 16 over 15. So that number is just a little bit bigger than 2, but that's my answer here. So how about 0? So if I have some number a and it's raised to the power 0, then the quantity, the answer to that is 1. So that might be counterintuitive. The exponent is telling me how many times do I multiply this number by itself. And then I say 0. So you multiply this number by itself 0 times. What do you end up with? 1. Well, you might think, why wouldn't I end up with 0? Because I'm not doing anything. And that's a valid thing to think. And the reason is, the reason comes from a math class that's a little bit higher level than this one. But the definition that you'll find in that math class is that there's concepts in set theory, and in particular, these are called groups, because there's one operation, there's a group of, I don't want to get into group theory, but there's an additive identity, which is 0, and there's a multiplicative identity, which is 1. And so, if I'm adding numbers together, this is very much an aside and not college algebra, but just in case you're interested, the additive identity is 0. That means if I'm thinking about 3 plus 5, what you're actually doing without knowing it in this scenario is you're starting with the additive identity, which is 0. And that's the additive identity because you can take any number and multiply or add 0, and you'll end up with the same number that you started with. So what you're actually doing when you add 3 plus 5 is that you're starting with the additive identity 0, and then you're adding 3, and then you're adding 5. You get 8. And so if I'm doing 3 times 5, what you're actually doing without realizing it is you're starting with the multiplicative identity 1. And it's the multiplicative identity because you can take any number and multiply by 1 and get that same number. This is not college algebra, just in case you're interested. So 3 times 5 is equal to the multiplicative identity 1 times 3 times 5, which is still 15. But you just start with 1 because you're doing multiplication. And so, in this scenario, a to the power 0, I'm starting with the multiplicative identity 1, and then I'm multiplying a 0 times, so I just end up with 1. So if you're interested in that, and reading more about that, look up additive identity, which is 0, and multiplicative identity. Which is 1. In college algebra, you just need to know that if you raise a number to the power 0, you get 1. So it might occur to you, what if a is 0? What is 0 to the power 0? That's strange, right? I don't know. I mean, it can't be 1, right? Because you're starting with 0. That's pretty strange. But maybe it is 1. That's one of those things. There's probably discussion about that on the internet. But you'll never be asked that in college algebra. Not seriously. What about the exponent 1? So this is a simple one. If I have any number a, including 0, and I raise it to the power 1, I just get a. That means, now that we know about the multiplicative identity, that means I'm starting with the multiplicative identity 1, and I'm multiplying in a once. So this is 1 times a, which is a. And now here's a neat one that you'll probably use in calculus further. But this is the minus the -1 rule. So the idea here is that if you just have -1 and you multiply it by -1, you'll get a +1. And if you take that and multiply by -1 again, you'll get a -1. So now this is -1 to the power 3. And then if you multiply again by -1, you get a +1. So this keeps switching back and forth between -1 and +1. And so what I'm saying is -1 squared is 1. -1 cubed is -1. -1 to the power 4 is +1. And you can see the pattern emerging there. When the exponent is even, you get a 1, +1, and when the exponent is odd, you get a -1. So this can be written as a piecewise function. -1 to the power n is equal to, and then these are the two scenarios. If n is odd, the answer is -1. If n is even, the answer is +1. So for example, what is -1 to the power 35? Well, 35 is odd, so it's -1. Well, I'll stop there. If you have any questions about anything, leave them in the comments below, and I will respond to your questions with more videos. So, thank you. Thanks for watching. If you thought it was helpful, click the like button. Be sure to subscribe to get more videos like this in the future. And if you have any questions on what we covered today, leave them in the comments below. For Dr. Smith's math class, this is Dr. Smith. Class dismissed.